you like a desiccant pack?
Yes.
Okay, fresh.
Do not eat.
Yesterday is gone, forget about tomorrow and the ceilings you see right through. Find the moment and make it. Write your headline and raise it to the sky. No one else can create it. Take your banner and raise it to the sky.
Hey guys, welcome to part 3 of our power series. If you missed the first 2, which would be solar, as you see behind me, and our Tesla battery bank, make sure to jump back in the playlist and watch those to catch up. Today we're going to be covering our inverter charger, which takes all that power and converts it into AC for us. Then we'll be talking about our Autotransformer, which we'll get to, and we'll explain that later. And then we're going to be talking about our DC to DC converter that's going to take this big monster 48 volt battery bank and allow us to use all of our 12 volt gear and appliances and equipment on the boat. At the end of the video, we're going to be doing a schematic that's going to show all of these systems, how they all tie together, and hopefully kind of tie it together for us. Next week's video, make sure that you stay tuned and subscribe down below for that one, and click the little bell and we'll give you an alert. That video is going to be about our consumption. So all the equipment that we put in, how do we use it, how fast do we go through it, and how fast does it charge. So thanks for watching. Hope you enjoy this. I hope it's helpful, and if you have any questions, make sure to comment below or send us a message. Okay, all right, we're going to unbox the 15,000 watt inverter. All right. 48 volts, 15,000 watts, DC to AC charger inverter, weighing every bit of 200 glorious pounds.
I feel like this is excessive.
Maybe. But somebody wanted ice makers and
You wanted the ice maker.
induction burners, and so we're gonna try to pick it up and see if we
Rest
can
it
get
here?
it. Yeah, let's rest it here,
And then put it
and then we'll stand it up. So we need to
Oh Jesus.
we need to get out of here so we can figure out where the mount plate attaches to the back. So I know how high to mount the mount plate.
I don't need an
inside.
explanation of that. This is gonna hurt.
All right, get her done. 3, 2, 1.
Oh dear Lord. Okay.
Here.
Are you gonna lay it on its back or are you gonna put it up on its feet?
For right now, I'm gonna lay it on its back. Just grab it underneath.
Yeah.
3, 2, 1. Stand up. Stand up. 1, 2, 3.
It's gonna come back my way.
I got you. No, let it down. Let it down.
It's all you.
Perfect.
Would you like to
Okay. It's heavy. And I'm trying to get it in before the girls get back. So there's not enough leverage and I'm not strong enough. Because obviously you see how awesome I am in shape, moving 200 pounds around. So I'm gonna use the straps to kind of strap over the cabinet and then use the ratchet to kind of help me pull it up. And if I can get the ratchet strap to pull it up, then hopefully I'll be able to swing it in and be able to get it on these hooks. Once it's on the hooks, screw on the side, locks it in, it's never gonna go anywhere. So, see what happens. Well, it's down on the bracket.
On the top and the bottom, or just the top?
Top and the bottom. But it's in.
Sweet.
All right, I didn't get any actual video of the Autotransformer going in, but I'll show you a picture of it right here. And instead of trying to go through all of the explanation of what it does, I'm going to explain that in the actual schematic portion of the video at the end, which will make way more sense. So I know it's currently a mysterious blue box, but it actually does something very, very important, and we need it so that we can produce this level of power on the boat. All right, on this windy day, we are going to make our DC to DC converter, which is going to allow us to go from our 48 volt battery bank down to 12 volts to run all of our equipment, including big stuff like 150, 175 amp winches and windlass on the boat. So we've got 4 of these. We've got some resistors, we've got some diodes, capacitors, all kinds of fun stuff, and we are going to assemble all of this on that board that's going to go over top of our battery bank to protect the connection so that we don't get any accidental shorting if anybody gets in there and works. So let's get started. Capacitors, resistors. This will cut the noise out so we don't get any interference on our electronics, navigation and what have you. And this resistor will change this output. This is a diode, so as the electricity flows through this, it's like a one-way valve. Electricity can only go through one direction and it can't go back. So in case one of these goes bad, or there's a big surge of power back through the system, electricity can't go back in and short out our DC to DC converters. Conversely, if one fails, we still have 3 backups and we can still run. You cannot buy a 200 amp DC to DC converter that goes from 48 to 12 volt. So we're making one. Each of these does 50 amps, and each one of them is capable of doing 600 watts of conversion at 12 volts. So 2400 watts, no, bear with me, I'm sorry, yeah. 2400 watts and 200 amps at 12 volts.
Do you still have more flux capacitors to put on?
I do.
These are fuses.
These are 30 amp fuses that will protect from power surges each individual converter. And we've got backup. just have to go test it.
It's kind of scary and exciting all at the same time. Let's go test it. Okay, so you had an epiphany. What's your epiphany? What'd you forget?
I forgot to connect the PC connections.
What is a PC connection?
It is the connection that talks to the other controllers when you've got more than one and you're running them in parallel. It tells them at what frequency they're supposed to put out electricity. And it's currently God knows what time. And I've been working on this for over half a day. We're going to be testing for 48 volts.
Oh, I was going to look at that. That's cool. 6.
I don't believe that they're faulty. I believe that it is operator error. Ooh, that was...
Will you just focus on what you're doing at the moment?
I just bumped my elbow while holding a wrench on 48 volt. Bumped my elbow on the ground wire for these batteries. And that got my attention. Okay. It's a long day. Solution did not work. We will be attacking this in the morning. But we don't play with dangerous stuff when we're tired. Come with me. Let's go cook dinner.
So I'm getting 48 volts in and 6.28 out. And I'm wondering if these resistors we put in are, these trimmable resistors are causing the issue. Oh, you did send me a schematic. Let's see here. So if you look at that data sheet and you scroll, let me get it up here. We were going to do an N+1 configuration that was trimmable to bump us up to like 13.2 volts.
You say you get 6.25 volts outs. I wouldn't expect the device to trim down that far.
Right. And it's a full 48. I mean, obviously we have a variable input voltage based on state of charge, but I'm currently sitting north of 48 volts on the input.
But the good news is, what?
It works.
He figured it out.
Yeah, so these are DC to DC converters, so 48 comes in here, 12 volt comes out here.
And it was built and intended to do that purpose.
To do just that. Now you can adjust it in what they call trim, which you can increase or decrease the voltage by the types of resistors that you add in. So through all that research, I found out what type of resistor that I wanted to use to trim up the voltage, because we want this to come out of here at over 13 volts. So if we get any voltage drop across the boat, that we'll end up with 12 volts or more at any of our appliances.
So you're super happy at 13.1, 13.2.
Yeah, that's exactly what we want. Before we were getting
6.1.
So these little guys are little jumpers, and they're placed in a strategic spot to jumper across some of these wires for a certain function. That function I thought was this function, and in fact it's not, so I removed all of them, reattached everything again, and we are getting awesome power, and I will show you. So we're coming in here 48.75, 74 comes here. So
Okay.
we've got good voltage, and now coming out, all of these come together. And the cool thing about this system is that this configuration is, yes, in parallel, but they all operate independently of one another, and none of them know that the other one is there. So these little guys are diodes, so the electricity can flow this direction, but it can't flow back. So in case one of these goes out, it's not going to be pushing current or more current back through the other ones and cause any damage. So they all operate together unbeknownst to each other. And this is, again, like we talked about before, our layers of redundancy. We actually could operate the boat with one for critical systems. We have to hand steer the boat and hand crank the winches and windlass. 2, we can operate a winch. 3, we can operate a windlass. And 4 is for security and having an extra. So we now are putting out 13.18 volts, which is awesome. And each of these will do 50 legitimate amps. So we can put, with this setup, 200 amps of power will run through these 3-aught cables. So if we need to be running a lot of power on the boat, we can do that and not have to have 2 battery banks, not have to have a 12 for the 12 volt system and a 48 volt for the house. We don't have to change any of our winches or motors on our windlass or any of the other equipment. We don't need to upgrade or downgrade or change any of that equipment. So we're able to leave the boat and all of its systems originally as intended, just with a massive battery bank and a ton of storage capacity.
I'm going to interrupt this video really quickly just to let you guys know that we have a special offer that has been put out there for all of our viewers from Inverter Supply. We bought all of our equipment that you see in this video directly from them with no discounts, no additional incentives or anything. We just researched the company, got some exceptional customer service and technical support, told them about our video, and they offered to put out a coupon code that we can pass along to you. So you'll find that code in the description below. Please use Inverter Supply if you would like to get an additional discount on any of your Victron products.
All right, guys, I promised you a schematic. So I'm going to give you a layout of all the components that we put in the past 2 episodes, so that you can kind of see how the entire system goes together. And then when we get to consumption, we'll talk about use and is it enough and all of that fun stuff. So we start with the sun. Our boat, we really want it to be as much as possible an all-electric boat. And the reason we built this system that I'm about ready to describe is for that reason. We will have propane hot water heat, and we'll have a propane grill, and we're going to have a propane pizza oven. Other than that, everything else on the boat we want to be electric. In our first video in the power series, we put in 2,000 watts of power. Since then, we've added an additional one. So we currently have 235 watts of solar power. That took us to our next video, where we ran everything down to our Tesla battery bank. That Tesla battery bank sits below the starboard aft cabin bed, and inside of that we have 10 Model S modules. Those modules are approximately 235 amp hours at 24 volts. We are running them in series and parallel. Go back to the other video again and you'll be able to see how all that's laid out. But what that gets us at the end of the day is a 48 volt system that has about 1,000 amp hours of usable 48 volt power. Now, from there, we take the power out with 4 big monster 3-aught cables and run it to one of the coolest things on the boat, which is our VICTRON Quattro inverter charger. And this does a couple things. One, it inverts power, obviously, to go from DC to AC. And it does that to the tune of 15,000 watts. And it also has 200 amps of charging power. Now, that 200 amps of charging power only comes from a shore power or a generator. We have run 200 amp hours into the boat. If you guys are wondering, when you kick that up, it's pushing almost 11.5 kilowatt of power an hour back in. So if you do the math, you can see how fast this actually adds up. By the way, to jump back really quick, for those of you who haven't seen it, 1,000 amp hours, it's roughly 53 kilowatt hours of power. And we are only using, by our choice, 90% of that. Back to the inverter charger. Now, out of the inverter charger, 15,000 watts. The reason we chose that size is because we want to be able to run everything at one time. And the next video, when we get into consumption, we'll talk about what the loads are and how we did all of our formulas to come up with that calculation. But to be able to use this power, interestingly enough, the Quattro from VICTRON, to be able to get 15,000 watts of power, they only make it in a European version, which is 230 volts, which is standardly runs at 50 hertz, which we cannot run any of our US appliances on that. However, they do have an option in their software to convert this over to run at 240 volts. And I can select or change the frequency at which it runs to go to 60 hertz. So now we can run all of our US appliances without damaging them and make sure all the clocks run like they're supposed to. However, we do have a little bit of a glitch with that, and solving that glitch actually gave us two benefits. To solve the glitch, the problem that we have here is that there's only 3 wires on a 230 volt European system. They've got a hot, a neutral, and a ground. Not to bore you, but those of you that don't know, when you plug something into your wall, you've got a hot, which is a little spade, a neutral, which is the big one, and then that round plug at the bottom is your ground. So they it's wired similarly, but the voltages are completely different. Where that comes into a problem is that in the US, when we run 240 volt stuff, 240 volt at 60 hertz, we use what they call split phase. And split phase means instead of having one hot, you've got 2, and they share the load. So the problem that this creates is that there's only 3 terminals on this inverter charger, not only to put power in, but to take from a generator or shore power, but also for it to push power back out. So in order to run our appliances with a neutral, we have to create one on the boat. And that's where the magic blue box comes in. We're going to take out of this box 2 neutrals, or sorry, I apologize, 2 hots, we'll call it line 1 and line 2, and a ground. And that goes into the magic other blue box, which is the Autotransformer. I have no idea what all options are for the Autotransformer and why in other applications you might use it, but for us, this is why we're using it. When we put these 3 wires in, it will actually take and run the 2 hot phases out that was coming out of the Quattro, because remember, we programmed it to come out at 240 volt at 60 hertz, and it's then going to bring the ground out. But inside this box, it's going to create a neutral, and that neutral is going to allow us to run 110 volt appliances through all of our standard outlets. The benefit that this gave us is 2 things. One, it allowed us to buy a converter that was actually 15,000 watts and convert that power into usable 60 hertz. But 2, it also prevented us from ever taking a neutral off of a dock. And anybody that's ever spent time around, especially in third world countries or some places that the quality control isn't quite what it needs to be, knows that if you don't properly wire 240 volt with neutrals, you can actually create straight current through the water, which can electrocute fish and people, and it's very, very dangerous. So we now have isolated all of that neutral phase inside the boat, and it kind of creates our own little power plant cocoon that we're protecting not only the equipment but in the boat, but also the people out and around it. So now that power comes out of the Autotransformer, and it's going to run into our AC panel. These 4 wires come in, and we now have a hot, a neutral, and a ground, or also known as line 1, line 2, neutral, and ground or earth. Okay? We can run 240 volt appliances, which will be things like our air conditioners, our oven, cooktop, potentially a dive compressor. And then, of course, we can also run all of our outlets. Now, when we put all this together in the boat, we thought, hey, it's all wired up, no bubbles, no troubles. Well, that's not true. The boat was originally wired to be, from the factory, a 110 volt or a US wired boat. But they didn't change any of the wire. They still used European wire, and they all run 230 volt, which is higher voltage, but essentially lower amperage appliances. Well, when you take a United or US microwave and our awesome microwave, which is also an inverter microwave, and that thing has 1200 watts. Okay, it's not a big deal, everybody says. Well, it actually takes more electricity than 1200 watts to get 1200 watts of cooking power. It actually takes somewhere around 2200 to 2400, depending on power surge and settings and what have you. Now, what that translates down to is high amperage on 110 volt. And that 14 gauge wire that Lagoon actually wires the boat with was not sufficient. So the wires actually started heating up because they just couldn't carry the amperage. So we paused, pulled all of that wire out of the boat, and rewired everything with 12 gauge tinned Anchor wire. And of course it's copper. So not only do we have more corrosion resistance in the factory, but we also are going to have a higher amp draw. That, or capability. That 12 gauge wire will be able to run our air conditioners. We were able to provide enough power to our oven, and that's in the spec range for the amperage and wiring. And every single outlet in this boat is either dedicated or shares with only one or two other outlets, a 20 amp circuit. So you can plug just about whatever you want into every outlet, and this inverter will safely push power through this panel and provide you uninterrupted, stabilized power. Now, the other thing that we've done out of this big old battery bank is our DC to DC converter. This is probably one of the coolest things on the boat, and it's not just because I built it. So when I was looking at this project, I thought, hey, 48 volt is really efficient. I can, of course, run all these batteries in series and get 48 volts, and I'll be able to then do a 15,000 watt inverter, and all that was fine and dandy. And I thought, oh, I'll just buy a DC to DC converter like everybody else does. Where's the problem? Nobody makes a DC to DC converter that goes from 48 to 12 volt. And that's the big rub. You got 48 volt to 12 volt. You can buy a lot of these for fairly inexpensive. And the problem is they all cap out at about 35 amps. And, well, what's the big deal? You say 35 amps is a lot. And it is. If you're running things like navigation or water pumps or things like that. Problem is that our windlass runs through a meter, actual lifting up half-inch chain and a 105-pound anchor. It runs about 175 amps at peak. And we have one powered winch on this boat, and it is a Harkin 60 for our main halyard. And that pulls about 153 amps. So now we're in a pickle. What do? We have all this power to run all this AC voltage and AC appliances, but we don't have the ability to push enough amperage to run, well, the big heavy loads that we have on DC. So I searched and searched and searched and couldn't find anything available. In fact, the closest thing I ever even found was from a car manufacturer that was trying to make a kind of like a power wall type setup to be able to charge an electric car. So what we did was I built this DC to DC converter that you saw. And the really awesome thing about that is we now have 200 amps of conversion at nearly, it's about 98.5% efficiency. So we have a tremendous amount of amperage pushed through and a pretty wide temperature range. And all of those DC to DC converters are actually sealed, and they're not IP68, but they are extremely water resistant, and there's no open fans or anything like that to get corrosion in. I'm sure somebody's going to be asking about that. All the connections are tinned, and they're sealed finned units. So, from the power out of the DC to DC through the DC to DC converters, gets us that 200 amps at 12 volt. And you heard me talk about the redundancy in the different systems. It is, no matter how many of those are running, we're still able to run our critical systems on the boat. So with that 200 amps at 12 volt, we now can run all of our DC equipment and all of our AC equipment through the Quattro section, and that is how we rewired and built this system together. Now, we will be going over in a future video consumption, and I know you guys are going to be dying to know, well, does it work or does it not? Well, I can tell you that it all works. What kind of consumption we're going to use, we're currently logging data, and we'll figure that out, and we'll share that with you, the more things that we plug in and use and operate, and we'll also track sunny days and what have you. So make sure to stay tuned for that. We'll absolutely do an in-depth video. Hopefully it'll be a little bit entertaining and not boring, but we do want to give you guys as much information. So those of you that stuck through this, thank you, and I hope this really helps. Don't forget, again, like, subscribe, and click that little bell again so you can see when we post a new video, and you can follow us along this rebuild and refit path. Have a great day, guys. See you next week.
No one else can create